Okay, guys. So yeah, welcome back. We're gonna do a binary tree in order traversal today. So this was a quite an easy tree graph problem where we can solve using recursion. So this is we can solve using recursion or iteratively. The recursion is quite trivial, not really trivial, I'd say, but we are trying to in order traversal. So what we do is we go to the very left node, and then we can't go left anymore. We record that node onto our output array, and then we go into the right node and then repeat the whole process. So we go to the right and then we go to the very left of that right one. And then if we can't do it, we add that. So for example, we go to the very left four, can't do anymore. So we add four and then we go, there's no more right. So we go up one, we add the two, go to the right. And then we see if we can go to the left again. We can. So we go all the way down to the left and do it again. So let's try to do the recursive solution for this. So let's try use the recursion solution. So we do need a helper function for this, where this is going to take in a node and the current array that we have. Yep, so we're going to be calling the DFS with our root node and an empty array. First thing we do need to check if there's no root. If not root, we will be returning an empty array. So this is nice and simple. We're just going to be calling itself for the left node until we get to the very bottom. And then once we get to the bottom, we will be appending the node value. Yeah, so we actually need a base case for DFS. So if we are at the bottom, so if the node doesn't exist, we're simply going to return. And that means that's the end. We're at the very left of our array. Once we're there, we can add this node value to our array. And then after that, we can do the same DFS for the right node. And then if we go into the right node, it will start doing all that's left again. And eventually, we'll be able to return the array. So this is the recursive solution. They say it's quite trivial, but it's quite hard, I would say, for someone who's never really seen LeetCode like that. So let's go in ahead and let's try to do the iterative solution for this. So the iterative solution will be we'll be using a stack of an array. We'll be inserting nodes into it, and then we need our root node, which is going to be new. So while a node is true, or while a stack is present, what we actually want to do is we want to add. So first things first, right? We want to add all the things we can to the left. Yep. So stack.append.node.left. Left. We also need an output array. Then we also need to update. Oops. We also need to update. Yeah. Cool. Now once we're out of that, we want to append. Oh, nope. What we want to do is actually um, we want to pop from the thing, and then we want to output. We want to append this value to. Let's think about it first, okay? So 7. Let's say I have one like this. What's it gonna look like? So node stack is empty at this point. So 1. While the node is there, we add it to our stack. We go to our left, and our node is. Oh yeah, there we go. Cool. So so basically what this is while the node exists, we're going to add it to our stack. Then we're going to try to update the node to the left. If it does exist, we're going to simply keep on adding it to the stack. Now, if it doesn't exist, we're going to pop out the very bottom. We're going to pop out the very bottom. And then we're going to append its number in. Then we're going to set the next node to our right. Now, the node is none there, right? So a node is none and this is none. So we're going to pop out the next one, which is 2, add it to our output array. And then simply we can do the right one. And then since our node does exist, we can actually start here, node left, and then go to the left again. So this is going to be an iterative solution for binary tree in order traversal.